Bismillahirrahmanirrahim. Assalamu alaikum. In this video, we are going to solve another question and we are going to learn a new concept known as the recurrence relation. So, before that, I would like to explain that what is a recurrence relation. We have a recurrence relation. We have recursive sequences, for example, 1, 5, 9, 13. So we have the recursive formula xn equals xn minus 1 plus 4. Now what is the main feature in this problem? What is the main feature of this formula? It is the formula itself. The next term should be expressed as the term of its previous terms, and the first term should be stated. Or if we are expressing the next term as a sum of the two previous terms, the first two values of the sequence should be stated, and so on. So since only one term is required to generate the next term of the sequence, we will write x1 equals 1, and we will also state the value of n is greater than or equals to 1, because it will not work for x0. We do not have any value of x0, so n should be greater than and equals to 1. The value of x1 should be stated, and then respectively we would have the values of x2 and then x3 and then x4 and so on. So this relation, this the whole relation, including the recursive formula, including the range of n, and including the first term or the first two terms, it is known as the recurrence relation. Now moving on to the solution, we are formally starting it. The first part, let me write the equation again. Just note the question: find a quadratic equation whose roots are alpha and beta, alpha square and beta square. So on the next page I would write the equation again. X square minus 3x minus 1 equals 0. We have to find a quadratic equation whose roots are alpha and beta square. So starting off with part 1, uh, we are going to calculate the sum of the roots of the new equation, that would be alpha square plus beta square. This is the sum of the roots of the new equation. The new equation have roots alpha square and beta square, and this is the sum of the roots of the new equation. So solving it, we are going to obtain minus b over a, that is equals to sorry, this is the roots of the previous equation. So we would obtain alpha plus beta whole square minus 2 alpha beta. This would be the sum of roots, and it should be equals to minus b over a, and that would be equals to 3 square, and the product of roots should be equals to c over a. That means the product of the roots is equals to minus 1. So just computing the value of alpha square plus beta square, we are going to get 11. Now we have to find alpha square and beta square, the product of the roots of the new equation. So that would be simply equals to alpha beta whole square. So now we are going to substitute the value of minus 1 into this expression and we are going to obtain 1. So our new equation is going to be x square minus sum of root x plus product of roots equals 0. That is equals to x square minus 11x plus 1 equals 0. So we are now going to obtain an equation with related roots. In the part 2, we are required to compute 1 upon alpha plus 1 and 1 upon beta plus 1. We have to compute the value of this. So just if we take the LCM of this equation, we are going to obtain alpha plus beta plus 2 in the numerator and alpha plus 1 multiplied by beta plus 1 in the denominator. Alpha plus beta, now I'm going to continue over here. Alpha plus beta bracket whole of plus 2 upon alpha beta plus alpha plus beta plus 1. So now we are going to substitute the values of alpha plus beta, that is equals to 3, and alpha beta, that is equals to minus 1. So we are going to substitute the values of these in this expression. So now we are going to get 3 plus 2 over minus 1 plus 3 plus 1, that is equals to 5 over 3, and that should be equals to 1 whole 2 over 3. So we have computed the value of 1 upon alpha plus 1 plus 1 upon beta plus 1. Now just look at the third part. I'm going to write it on the next page all over again. Let alpha and beta be the roots of the equation. We are going to do it on a fresh page. X square minus 3x minus 1 equals 0. Find the recurrence relation for xn equals alpha n plus beta n. So we have to form a recursive formula for this. We have to express the next term in terms of the previous two terms. For example, we have alpha square plus beta square, and we should be able to calculate the value of alpha cube plus beta cube using the recursive formula, and using this value we should be able to calculate the sum of the powers raised to the power of 4 by using the sum of the cubes of the roots. So the process is entirely simple. We have an idea of the method using the previous videos, so just look at the methods carefully and you would have nothing to complain about. We are substituting the value of x equals a and the equation will hold true. We will substitute the value of x is equals to a in this equation and the equation will hold true. So we are writing this equation, and the same will hold true when if we substitute x equals b into this equation. Minus 1 equals 0. Now we will multiply both sides by a raised to the power alpha raised to the power of n, and the equation will again hold true, because if we multiply a raised to the power of n with the right hand side, it will remain 0. Now we will do the same in the next row, and if we add them, we are going to obtain alpha n plus 2 alpha raised to the power of n plus 2 plus beta raised to the power of n plus 2 minus 3, alpha raised to the power of n plus 1 minus beta raised to the power of n plus 1 minus alpha raised to the power of n minus plus beta raised to the power of n equals 0. So now we are going to obtain this should be equals to x n plus 2. This should be equals to x n plus 1, and this should be equals to x n. Then that should be equals to 0. So we are going to obtain the recursive formula x n plus 2, and that is equals to 3x n plus 1 plus xn. Now we are going to define the value, the range of n that should be greater or equals to 1. We have the formula over here, and we have the value of we have the range of n over here, but still one thing is missing. We have to find the value of x1, and since for the next term the previous two terms are required, we have to write the first two terms as a result. So we need to find the value of x1, and we need to find the value of x2. So now we know that the value of x1, that is x1 equals alpha raised to the power of 1 plus beta raised to the power of 1, that should be equals to alpha plus beta, and that should be equals to 3, since the value of minus b is equals to 3. So x1 is equals 3. Now we have already calculated the value of alpha square plus beta square in the previous parts, and that should be equals to 11. So the value of x2 is equals to 11 as well. So now we will be able to calculate the value of x3. And then we will be able to calculate the value of x4. So our recurrence relation is complete in this case. So this is the new thing we learned. We have learned how to obtain the recurrence relation for the sum of the roots of a quadratic equation raised to a certain power of degree. Thank you very much for watching the videos. Inshallah, in the next videos I will try to come up with the Olympiad problems in order to add to the interest of the listeners. Thank you very much.